All right, good morning, Vikings. It is Monday. Oh, I don't even know what day it is. Monday. Oh, it's going to be March 30th. Can you believe it? It's actually Sunday, the 29th, but I figured I better make this video today because I've already made a few mistakes and have had to start over. So hopefully this is the last time I'm going to pretend to talk to you, which is really weird, sitting here talking to myself on the iPad. But we're gonna see what we can get done today. So first of all, I hope you're good and safe and not going too much out of your mind, being stuck at home. I am really looking forward to starting a routine this week and getting back to some sort of schedule myself. So hopefully you're not too overwhelmed this week with everything that's going to be coming at you from your different teachers. And if you do feel overwhelmed at any point, you just need to let us know, and so that we know to kind of pull back a little bit and help you through. Because honestly, this is the first time any of us have dealt with any of this before. And so as long as you're communicating and talking to us, sending us messages and letting us know how you're doing with your work, and if you need help and when you need help, and if it's too much or if you want even more because you're bored, just let us know, and we'll do whatever it takes to get through this together, because this is a hopefully a once-in-a-lifetime experience, I'm hoping. But who knows? But the next time we'll all know what we're supposed to be doing a little bit better. So I'm out here on my porch. Hopefully the wind in the background's not too much, but I'm going to try to help you remember what we were actually doing like 2 weeks ago. And so I'm going to kind of turn off the camera here and move to a smart look and take you back in a time machine to, well, it's probably a little bit more than 2 weeks ago, and remind you of what we were actually doing in science. So we had just finished looking through the microscopes at a bunch of different things, and the reason being was we were on the lookout for cells. And so I think the very last thing we kind of did was we started to look at the different stations and think about what the stations had in common, and if there were any differences that we noticed, specifically between the stations that were either specimens from humans or animals and specimens that were from plants. So just to kind of remind you of what you looked at. You looked at station number 1. This was the cork. And station number 2 was the red blood cells. Station number 3 was the algae. Station number 4 was the onion root. And station number 5, you attempted to look at your own cheek cells, but if you didn't see your own cheek cells, there was a slide with somebody else's cheek cells. These are actually mine. And let's see, the next station was actually the pond water, which I don't have a picture of, but so we're just going to skip to station 7, was the Elodea, that aquatic plant that people often have in their aquarium. So let's go back to the very beginning and talk about some things that we noticed. So one of the things that we noticed was that in some of these cells, let's go back to the ones that were really good. There were these dark spots. In this case, in the onion, it was circle, more like a circle. In the cheeks, it tended to be a little bit more of an oval. All right, those dark spots are one of what are called cell organelles. So just like our bodies have organs that turn into organ systems that then create an organism like ourselves, cells Oh, there's the neighbor's dog. Cells also have organs, except we call them organelles. Organelles actually just means tiny organs. So this little dark oval or circle that we saw is one of their organelles. Specifically, this is called the nucleus. What's really cool, I just noticed right here, this is actually a cell that was in the middle of splitting in half. You can actually see right there where the nucleus was splitting in half. Anyways, other things we noticed. Well, a difference that we noticed was that all the things that came from plants kind of had a different shape. And so here's the quark, okay, more of a rectangular, squarish shape. Here is the onion, also a plant, also more of a rectangular, squarish shape. And the Elodea, which is also a plant, definitely more of a rectangular shape. So everything that is a plant, boom, boom, and boom, has more of a squarish, rectangular shape, kind of like a brick. When you did that activity with Miss Spratt, you talked about how the cells are the building bricks of life. Cells create tissues, which create organs, which create organ systems, which then create an organism. So that in plants, they very much look like a brick. In animals, like ourselves, our cells are definitely not brick shape. As far as our red blood cells go, definitely a circle. Let's go to our cheek. Not so much a circle, more of a blob. Scientists kind of call this irregular. And you will notice in a lot of our animal cells, and here's a whole bunch of different ones, there is no set shape. A lot of them are round or circular, but when you look like at our nerve cells here, they're kind of funky looking. And scientists refer to that as irregular. And so if I go up, and show you other things that you would find in a lot of animals, like our bone cells, they look a little bit more blobby. Our fat cells, let's see if I can get this to move up. There we go. Our muscle cells, now our muscle cells are certainly not circular. They're long and flat, definitely irregular. And let's see what else was hiding down here. Oh, kidney cells. Let's see. Yeah, they're kind of blobby looking. So there is pretty much a few differences between plant and animal cells. So over here is a plant cell. Over here is an animal cell. So one of the big ways to tell the difference is plant cells definitely are more rectangular. And animal cells, when you see drawings, are typically a blob, a circle, an oval. But just know, in real life, animal cells have all sorts of shapes. They're irregular in shape. Let's see. Let's go back to the Elodea. So I don't know if you guys noticed this when you were looking under the microscope, because they're kind of faint and they're very kind of foggy. But there are lots of little round things inside each of the cells. Now you might think that that is the nucleus, like we saw in our cheek cells, but these little things are actually something different. All of these are things called chloroplasts. And a lot of you might have learned about that word when you talked about photosynthesis last year in 5th grade. If you didn't talk about that, don't worry about it. We're going to get to it at some point this year before all is said and done. But those are actually the chloroplasts. Animal cells, we do not have those. So that's another difference. Oh, I think I hear one of my kitties. Oh, take a break. Take a break. I hear a kitty meowing at the door. There's one. Say hi. Hey. Say hi. And I hear another one meowing at the door. I better let her in, or she's going to be meowing the entire time. Tink? I thought I heard Tink. Okay, maybe she wasn't. Oh, there she is. Come on out. Yeah, come on out. Say hi, Tink. To your fans, say hi. Or turn your back. Yeah, don't worry about it. All right. So, you were able to see several of what are called cell organelles under the microscope. Another one you're able to see is the outline of the cells. So when you just look at the outline of the cell, that is what's called the cell, membrane. Whoa, there you go. So like if you had a balloon, a blown up balloon, like the outer part of the balloon would be your cell membrane. Okay, so each one of these cells has a boundary around it, and that is the cell membrane. Cell membrane. Cell membrane. Let's see. Cell membrane. Now, there is one difference. If you look here in the plant, in the Elodea, their cell membranes are kind of thick, okay? Especially when you look like at a cheek cell. If you go to the onion, okay, it looks like their boundary is a little bit thicker. That's because plants also have a second layer called the cell wall. I think Miss Spratt talked to you about that, about the fact that plants don't have a skeletal system. They don't have bones, they don't have cartilage, they don't have things that give them structure. So if cells and plants only had one layer around them, they'd be more blobby, like our cheek cells or our red blood cells, which are blobby. But they've got bones and a skeletal system to give the organism structure. Plants don't have that, so their cells have to have thick boundaries around them, which are composed of the cell membrane and a second layer called the cell wall. All right, so let's kind of move on. So I showed you this picture a few moments ago. So this is a drawing of a plant cell and an animal cell. This is not what they really look like in real life. Okay, this is just to make it more simple as you kind of learn the parts. Now you'll see a lot of things labeled on this picture, okay, but we're not going to learn all of these. I mean, you can, you got plenty of time, but the things you need to learn are, first of all, I've already talked about the cell membrane. Animal cells have it, and I just covered it up. Plant cells have them, right there. Okay, the next one you need to learn is cell wall. You're only going to find a cell wall in a plant cell. They need that extra layer to give them structure. Can't have a 100, 200, 300 foot tree without cell walls, because it would just be a blob pile of cells. Another one you need to know, this is one we actually could see under the microscope, is the nucleus. Those were those dark spots that you saw, like in your cheek cell. Another one you need to know is mitochondria. Mitochondria you can find in both cells. You'll learn about what those do this week. Another one you need to learn about is cytoplasm. That's in both types of cells. And then the last one you have to learn about this week, oh, no, I take that back, 2 that are left, is vacuole. And those are actually in both types of cells. There are no vacuoles in this animal cell over here, so I'm just going to make one, because there are vacuoles in animal cells. And now the last one is chloroplast. Those are only in plant cells. That's the one that does photosynthesis. All right, so to recap, in 6th grade, the only ones you need to learn about this week is nucleus, cell membrane, cell wall, plant cells only, mitochondria, chloroplast, plant cells only, vacuole, and cytoplasm. All right, so one way to... Yes? Okay, kitty cat break. Okay, so one way to learn the cell organelles is through analogies. So analogies are kind of like similes and metaphors that you've done in English language arts, like soft as a kitty. That's a metaphor. Similes, remember, you just add is or like. Soft, or I already did that. Soft as a kitty. That is a simile. An analogy is very similar. It's when you compare two things that are kind of similar, and you use it a lot when you're trying to explain things to people. So I have an analogy of the different cell organelles that I would like to share with you. We were going to do this at school and take a little tour of the school, and we were going to identify different parts of the school that would be related to the different parts of a cell. Well, since we're not at school and I can't take you on that tour, I'm going to take you on a tour of my house. And I'm going to point out different parts of my house that would be like the different parts of a cell. When we're talking about a cell or my house, we're talking about a system. So a system is a bunch of parts working together to make something successful. So your body, your organism, is made up of a bunch of organ systems. All those organ systems have to work together to make you work. And so a cell is also a system, and it's got little parts, organelles, that have to work together to make the cell work. If your cell doesn't work, then organs don't work, tissues don't work. That can lead to you being sick and lead you to having different diseases. In a house, there are different parts to your house that kind of have to work to make your house or your home work well. And so I get to be the nucleus. So if I'm the nucleus of my house, I want you to think about, what do you think the nucleus of a cell does? So Mrs. Bruns, if she was here, would be wearing a nucleus sign too. So if Mrs. Bruns and I are the nucleus, what do you think that means the nucleus does in a cell? What do you think we do as far as our house goes? So I'm going to flip this camera around and we're going to take a quick tour. Leave the kitties here on the porch because they like to just sit and relax. Maybe Tink will come with us. Will you come with us? Oh, okay. Belly rub. She likes her belly rubs. All right. All right, so we're going to go on a little tour. This is our messy downstairs. Oh, I do want to show you, just in case you care, I did bring the fish home. They are alive. I saw them this morning. They're probably in the castle. But the fish are safe and sound here with me. All right, so another organelle, cell wall. So the cell wall, oh, there's a tweet from Mr. Cunningham. All right, so the cell wall, hey, that is like the wall of my house. So just like if you took the cell wall away from a plant, what would happen to the plant? If you took the cell wall away, or took the wall away from my house, what would happen to my house? Gives you an idea of what it does. Over here, front door is like the cell membrane. So again, think about what a cell membrane might do for a cell. Now here's a little thing that my cell membrane or my door also does though. My cell membrane or my door opens. And so if my door is kind of like the cell membrane, what might the cell membrane actually do for a cell? All right, let's go upstairs. See